I have a dream. Now, you've heard a very famous person say that. But I do have a dream of having a building like this with the words Dinosaur Soft Tissue Research Institute across the front of it. Now, you might say that's shocking. Shocking. Who ever heard of such a thing? Dinosaur soft tissue. Well, I can tell you, based on my own work and the work of others, that dinosaur soft tissue is all over the fossil remains in the fossil record. We're finding dinosaur soft tissue in many places and from many different species around the world. Now, this cost me my job. Why? Because I went to the Hell Creek Formation after reading some of these publications, and I found a Triceratops horn, and I found frill, and I found condyle, a bone at the base of the neck of the Triceratops, and I found soft tissue loaded in these things, and I published it in a major journal, and it cost me my job, but I'm not going to talk about that because that's not what's important here. What's important is you're being lied to. You're being lied to by major mainstream science, which does not want to tell you about dinosaur soft tissue remains because it's explosive. Why is it explosive? Well, it can't be there. It shouldn't be there. If dinosaurs are 65, 75 plus million years old, which is what they're telling us, then none of these soft tissues would be there, but they are there everywhere. And so we've been working on this. I'm going to describe our project to you in this short video. And we may not be able to fund a $50 million dinosaur research institute to study soft tissue with this crowdfunding, but we do want to fund our project so that we can continue to go to these digs, to look for these remains, and to study them and publish them in major journals. You know, I studied under a professor, Dr. Richard Lumsden of Tulane University, who said to me, "My boy, don't be afraid of where your science takes you." And my science has taken me to the point where I'm finding these beautiful cells, beautiful tissues in dinosaur remains. And the question is, how can they be there? Well, the answer is they're not that old. If dinosaur remains are full of soft tissues, then the remains are young. If the remains are young, then the earth has to be young. And if the earth is young, that's a whole nother kettle of fish, isn't it? But we want to pass this information to the general public because you're being lied to. And so we're going to describe for you in this video the project that we've already done, our many successes, our dreams and our goals to continue this project so that we can get this information out to the average person who doesn't even know that dinosaur remains are full of soft tissues. Now, any laboratory that is examining soft tissues, whether it's from plant or animal, or in our case, in dinosaurs, has to use a standard of microscopy or microscopes to do the examination. Many scientists have published, and I myself have published papers using what we call light microscopy. And so behind me you see several of the light microscopes that I have in my laboratory. And we produce these tissues. We have to process them for microscopy, thin section them, stain them, and we put them on glass slides so that we can examine them under these microscopes in various modes of microscopy. And so we have a nice complement of light microscopes in my laboratory, and because I've been working with light microscopes for over 30 years, I know how to run all these very well. I know how to maintain them. I know how to repair them when they need repair. So we're really not looking for any funding to help us in light microscopy. We have that down pretty well. But this is the standard that any laboratory has to rise to in order to image the tissues, photograph them, produce nice images, and then produce the publications. And any scientist who's done light microscopy has published this. I myself have published many papers using light microscopy. So all this to say, we're doing well in the area of light microscopy for our laboratory. Now here are some of the successes that we've had using light microscopes with the dinosaur soft tissue, and you can see how soft and stretchy this is. This was a huge success. We found large sheets of soft bone tissue in this Triceratops horn from Hell Creek in Montana, and within these sheets are the tiny little cells, the bone cells, what we call osteocytes, that we also imaged using the light microscopes that I've just shown you. So we've had some great successes using light microscopy and publishing this. Now here's some examples of some of the cells. Here's one of the cells. This is a dinosaur bone cell. Here's another example. We'll go up in magnification here a little bit. And this has now been isolated from that soft sheet of material that you saw me stretching. So in that soft material that you saw, we found all these cells and we isolated them. So we've been using light microscopes very successfully to discover and promote and publish these cells. Now, in processing tissues, soft tissues for microscopy, they have to be thin sectioned. They have to be cut into thin pieces so that you can then mount them on a slide and stain them and examine them under the microscopes which you saw previously. But here we have a bit of a problem because we have a machine called a microtome. It's actually called an ultra microtome because it cuts very, very thin sections. This machine can be used to thin section tissue for light microscopy on slides and also for electron microscopy, which we'll talk about in a second. But this is a 30-year-old machine and it's showing its age. It's not cutting very good sections anymore. So we have a problem because we can't do microtomy or thin sectioning to very high standards. And so part of our budget calls for a replacement, a brand new microtome, or what we call an ultra microtome. So you'll see that in the budget at the end. Now, we use scanning electron microscopy to examine the dinosaur soft tissues, and you probably hear a lot of noise in the background. That's because these microscopes, electron microscopes, use a vacuum, so they're vacuum pumps. So I apologize for the background noise, but I wanted to show you that you are actually looking at live images of these cells. These are individual cells from a dinosaur bone, and I'm going to magnify up so you can see there is one beautiful dinosaur soft cell. So we're finding these cells, we're using this very expensive electron microscope, but there are problems. Some of the problems we're experiencing have to do with the vacuum and all the vacuum lines that are inside the microscope. And so we need a service contract for this instrument, about a $10,000 a year service contract to keep this instrument running. Now the other problem we're having is with the imager. And the imager takes the pictures, and I'm going to ask the camera person to pan over a little bit to this rickety microscope here. I'm sorry, this rickety computer. And I apologize for making her do this. But we're using the imager that's about 30 years old. So it's 30-year-old technology, and it's failing. I've got an external drive taped to the outside of the unit. It's very hard to keep it running. So I need a new imager, and that's another $10,000. So right here, just to keep this instrument running and to take the beautiful pictures that we're taking and to publish these is $20,000 just to keep this instrument running. And this is a 30-year-old instrument, so we're not using anything new by any stretch of the imagination. What you're looking at is the screen of a scanning electron microscope. And on the screen you see a Triceratops bone. This is from the Triceratops horn. And these are the blood vessels. These structures here are all blood vessels. And they've all been mineralized. They're all hardened. And we're going to zoom in on the surface of these hardened vessels where there's soft tissue. There's soft tissue still all over the surface of these. And so we're going to zoom in here, and you're going to see me focus in on some of the soft tissues that are here. Now, what you see are these white bands. And these white bands are all pieces of soft fiber or bone that are laid down on top of each other here. And in between those sheets are these little cells called osteocytes. And I'm going to zoom in. Right now I'm at 500 power. and I'm going to go in a little tighter, and you can see these 3 osteocytes here with these very beautiful filopodia all around the outside of them. They're all touching each other, and I'm at 2200 power right now, and you can see just how stunning these cells are with all these beautiful cell-to-cell connections, these filopodia. And I'm at 3500 power now, but let's zoom in on some of these little filopodia, and we'll go up to maybe 10 or 15,000 power. I'm at 11,000 power right now, and you can see how beautifully preserved these tiny little filopodia are, these little cell-to-cell extensions, because all these cells are touching each other. And so even at the highest level of magnification, 17,000 power, you can see the beautiful preservation. And so this is wonderful evidence of young tissues. These tissues cannot be old because they have these fabulous cells with incredible preservation. The other electron microscope that we use in this electron microscope laboratory is the transmission electron microscope, and it also uses vacuum pumps, and this magnifies very much higher than the other microscope that I just showed you. But again, this is now almost a 50-year-old microscope. Bear in mind that we are competing with multi-million-dollar laboratories that have brand new electron microscopes, and we're working with 30 and 50-year-old microscopes. And again, this one needs a service contract, just like the scanning microscope does. So another $10,000 for a multi-year service contract for this instrument to keep it running. And with that service contract, we can keep this running, and we will compete with labs who have brand new equipment. Now, as you can see, we're pretty well set up in this microscope laboratory to do all the conventional types of microscopy that are done by researchers in this field. However, there are times when the tissues that we work with don't respond well to the protocols for transmission electron microscopy or for scanning electron microscopy. And so there's a form of thin sectioning for tissues that just don't behave called cryo or frozen microtomy. We can freeze the specimen and we can thin section it very rapidly. You might have heard of a cryostat, which is often used in a hospital laboratory when they have a patient on the surgical table and they're fast sectioning parts of a tumor. And so this is a very useful machine that can help us and would round out the capability that we have, particularly with dinosaur soft tissues, because many times they don't respond well to the conventional protocols that we use. That would be another line item on the budget of about $30,000. So let's review some of the successes that we've had on this project. We went to Montana. We went to the Hell Creek Formation, where many soft tissue dinosaur finds have been made. And we found a large Triceratops horn, 48 inches long, and we found it full of soft tissue. And so we published that in a major journal. And in fact, we actually got a cover picture in American Laboratory. And so here is a shot of some of the soft tissue that appeared on the cover of American Laboratory. And we also published our findings, our paper, in a journal called Acta Histochemica. And the copy of the reprint is available. If you contact me, I can make copies of the reprint of the paper available to you. Now, we've also been to several meetings to describe our findings. We went to the annual Microscopy Society of America meeting in 2014 up in Hartford, Connecticut. But we've also spoken twice at the Southern California Academy of Sciences in 2013 and also in 2014. And we've been invited back to speak in the 2015 conference for the Southern California Academy of Sciences. So we've had a lot of success with the first project. But we went back to Hell Creek and we found Triceratops frill. Now, frill is the large piece of bone that comes off the back of the head. And this was also loaded with soft tissue. I also have here with me a Triceratops vertebra. We didn't look for soft tissue in this, but we did find the bone at the base of the skull. It's called a condyle. It's like a big softball, and it allows the Triceratops to rotate its head. And that condyle was also full of soft tissue. And so we've written papers and we've submitted those for publication, and those we hope are going to be published soon. So we have some successes. We've demonstrated that we can do this work, and that's why we're appealing for support and for funding, because we want to go dig a juvenile T-Rex and other dinosaurs that have not yet been studied for soft tissue. So let's review the budget that we've discussed during this video. The dinosaur soft tissue budget for hourly work, of course, zero. We're not charging any money for our hourly work. Service contracts needed, as we discussed. The scanning electron microscope requires a service contract. The transmission electron microscope requires a contract. Those are both $10,000 each. As far as equipment needed, we need a new ultramicrotome. That's $30,000. A new cryomicrotome, which is the frozen section machine, $30,000. And then for travel, we want to go back to the Hell Creek, and there's other digs that we'd like to go to. So we want to go back to Hell Creek, that's $3,000. Travel to the Texas red beds, which have yielded a lot of dinosaurs in the past, and also the Alberta Badlands, and so those would be $4,000 and $5,000 each. And so the grand total that we're requesting for funding is $102,000. So we think we can do some really world-class research if we get this kind of funding, and it will help us not only continue the good research that we've been doing, but do even better research as we continue. Thank you. What's the bottom line, folks? Well, here's the bottom line. If dinosaur remains have soft tissues in them, the earth is young. If the earth is young, then the Bible can be believed. That's the real crux of this matter. And that's why we're doing this project, and that's why we need your help. We need your help to give us a bridge funding. We're not going to get to the $50 million building with this crowdfunding, but we'll get to be able to do our project and publish it and get the word out to people around the world that dinosaur remains have soft tissue in them. And the bottom line is this. People need to know this. This is the truth. This fits with the Bible. It teaches that God is really our creator, that God really did create the way He said He did not so long ago, a short time ago, and that the earth is young. That's why we've stepped out. I've lost my job because of this, but that's not what's important. What's important is the truth of the science that's out there, and not letting science be hijacked by people who are going to lie to you and not tell you the truth. We're here to tell you the truth, to show you the truth, and to point you to the Bible, because the Bible can be believed. Thank you.